Okay, so this is the end of chapter 3. We'll get through this real quick, and then we'll go on to IB. Now, when we're talking about orbitals, remember that because they have their wave functions, remember I was referring to wave functions, so orbitals are actually composed of wave functions, okay? They're literally where things that have a wave-like properties, i.e. electrons, are located, okay? So just like your bathtub where you're splashing around, right? You can have constructive and destructive interference of the waves within the orbital, which would be your bathtub, right? Okay. Okay, so the amplitude of an electron's wave function at a particular point in space has no real physical meaning that we would actually understand having lived in this universe, okay? The square of that value actually gives the relative probability of finding the electron there, because it's hard for you to understand, but the amplitude would give you the sign of essentially the kind of like spin does, okay? Where you have a positive and negative, okay? If you square that value, they all become positives, right? And it gives you probability, okay? Kind of like if you look at a Gaussian distribution around 0, you have negative and positive, right? If you square that, you get just the 1. Okay, now the mapping of those probability values throughout space, that gives us the shape of this orbital. And this, when you see it solid like this, that means you have a 90% chance. Okay, so it's a 0.9 probability. Nodes are going to represent surfaces where there's 0 probability of finding an electron. So for example, right there, we see a node. So that node, you have a 0% chance of finding that electron. This right here shows you your opposite phases. Can everybody see it okay? Okay. And that's one singular orbital. Okay. All right, so this right here is the positive phase coming together, and this is going to be constructive interference. I'm going to come back in just a little bit, actually. Sorry, I've had a crazy day. I need to